Hi friends, welcome to the Unit 3 Day 1 notes. Jumping in now to our little side mission here with triangles. So we're talking about how many triangles are in each of these shapes. We cut them up in the last video, so now let's kind of digest what's really going on here. So in this first one, we talk about a three-sided figure, remember, is a triangle, and it has one triangle inside. And we know that the sum of the interior angle measures of a triangle. So if we measure using a protractor, that's a measuring device that allows us to measure angle degrees, we can add all of these up, and that gives us 180 degrees. Now we know also through measuring the outside parts of the triangle, so the exterior angles, that would measure up to, or add up to be 360 degrees. So now that we've talked about this, we have enough information now to fill out the rest of this table. So for this one, the quadrilateral has two triangles. You can see that from the example above. So the sum of the angle measurements of these triangles for the interior, now note this is interior, is that we have 180 and another 180. So we can take 2 times 180, and that gives us 360 degrees. Now we can measure the exterior part of this, and if we do so, we actually get that also adds up to be 360 degrees. What? Mr. Brummond, wait, I thought, but yes, if we actually measure a triangle exterior angle, here, here, and here, it's 360 degrees. Same with the quadrilateral, also 360 degrees. In fact, if you measure the exterior of any regular polygon, any polygon, all of the exterior angle measurements will be 360 degrees. That is a cool property that all polygons have. And also 360 degrees, no matter what. A pentagon has 3 triangles, so we would do 3 times 180. Now, if you can see the pattern, go ahead and pause the video now. See if you can fill out the rest of this chart without me going along each step away, and see if you can figure out exactly what's happening, especially when we get to the last one. So 3 times 180 is 540 degrees. A hexagon will have 4 triangles, so 4 times 180. And that is 720 degrees. And then a heptagon has 5. Now I didn't draw it, but you can feel free to draw it to verify. And that will be 900 degrees. Octagon has 6. 6 times 180 is 1080 degrees. So now we're getting into this little kind of pattern here where it says n-gon. So if you think about it, how many triangles are composed in an n-gon? Well, if I take the number of sides and I minus 2. In fact, you can see the pattern from each of these so far. To get to any of these shapes, we just take the number of triangles, the n, the number of sides, subtract 2, and we get the number of triangles that it has. That means to get this formula here, so we can now find out the shape, the sum of the interior angle measurements for any shape. We just take the number of sides that it is, minus 2, times 180. And that'll give us our total amount of degrees for the inside. And then this gives us the Polygon angle sum theorem. The sum of an interior angle measure of a convex polygon with n sides is n minus 2 times 180 degrees. Now, I said convex. Convex just means all of the polygons that we've drawn so far essentially kind of burst outward instead of being pulled in. So this is a pentagon. Now, a lot of people, another way that they think of kind of shapes is if it's something is kind of sucked in. So I usually draw a parallel between a pentagon and then a 10-sided figure that's concave. Concave means come in. I actually have an example behind me. The star on my tree is actually an example of a concave type of polygon. And because all of the points don't radiate out from one another, some of them radiate in. So they are all connected and they're all side measurements, all line segments, but they all don't work the same in terms of concave and convex. That's what convex means. So here, let's go ahead and find the sum of the angle measurements of the interior angles. So it's important to note that, and that's why they also bolded so we could see it, of the indicated convex polygon. So again, we're going to assume it's convex polygon unless it tells us otherwise. So a dodecagon. First, we need to figure out what a dodecagon is. If you forgot, you can flip back to the front because it's not on this page. Dodecagon is something that has how many sides? So checking, a dodecagon has 12 sides. So a 12-sided figure. So again, I'm going to use my formula that I have on here. So this is 12 sides. So I'm just notating that for my own kind of benefit here. So we're going to do 12 minus 2 times 180 degrees. 12 minus 2 is 10, so I'm going to do 10 times 180 degrees. And 10 times 180 degrees is 1,800 degrees. I do need to put the degree symbol there to showcase that it is actually a measurement. An undecagon has 11 sides, or an undecagon. So because it has 11 sides, that's what goes in for my n when I plug in my formula, times 180 degrees. So here I have 9 times 180 degrees. Oh, I moved my parentheses. It'll still give us the same answer, but I want to be consistent. Times 180 degrees. There we go. And then this will give me 1,620 degrees. Now we're getting into angle measurement, or sorry, sides, angle sides that we don't have names for. 15gon, we know that that actually has 15 sides. So we're going to plug in 15 minus 2 times 180. So that's going to be 13 times 180. And 13 times 180 is 2,340 degrees. Now you see, out of habit, I'd put a comma there. I normally don't put commas in these answers as I write them. You can, it's okay to do so. I usually don't because it gets a little bit difficult to read the commas, periods, and whatnot, but it's all okay. It's all okay to do that. 40gon has 40 sides. So then plugging in, that's going to give me 40 minus 2 times 180. So 40 minus 2 is 38. And 38 times 180 is 6,840 degrees. So the sum of the measures of the interior angles of the convex polygon is given. Classify the polygon by the number of sides. What it's giving us now is the final result that we were establishing earlier. We need to now work backwards using this formula to find the number of sides. We know that if we get to that end part, we can have it. So essentially what we have is we have that formula. So I'm going to go ahead and copy the formula down. N minus 2 times 180. And what we're saying is that this final result is going to give us 1,620 degrees. Now you already know the answer to this because it's literally right here. And I gave this problem so you could see how this journey gets us to getting to 11 sides and then classifying it as an undecagon. What we want to do first is get n by itself. You remember this back from last year in your math course where we would then divide by 180 on both sides. So we're left with, after this simplifies to 1, be careful, don't call it canceling. Canceling is when it makes it 0. Simplifying is when it becomes to 1. So this gives us n minus 2 left on the left side. And then 1,620 divided by 180 is actually 9. Now to get n by itself, we add 2 on both sides using our addition property of equality, which I'm sure you remember from the previous unit. And that gives us n equals 11. So this is an 11-sided figure, or an undecagon. You also know 540 degrees, so we're just going to continue to showcase this, drive the point home so that we really understand how to find it. So again, I'm setting everything up using this formula that we established earlier, and then setting it equal to the number of degrees that it gives us. We set it up exactly the same, where we divide both sides by 180 degrees. This simplifies to 1, so we're left with just n minus 2 on the left-hand side. 540 divided by 180 is 3. Add 2 on both sides, and we get n equals 5, which is a pentagon. Oh, sorry. Pentagon! There we go. And then for this last one, this 2,520, again, n minus 2 times 180 equals 2,520. Divide both sides by 180. I'm left with n minus 2 equals 14. Add 2 on both sides, and you get n equals 16. Don't forget the name of a 16-sided figure is an n-gon, but n has to be the number of sides. So you couldn't call this an n-gon and get full points. It is a 16-gon. All right, join me in the next video as we go through and find the value of x using information we know. Have a wonderful day.